Hey, are you looking to succeed in mechanical engineering? There are a lot of skills that you need to know to excel. Today we're going to talk about the top 8 that you need to know to succeed. My name's Farhan. I used to be an Apple engineer for many years, and now I'm a CTO of a startup. So we'll start off by talking about the first skill, a strong mathematical foundation. So while in school, we learn a lot about these different mathematical foundational principles, from mechanics of deformable solids to calculus and other things. And it's very crucial that you have a solid foundation in these subjects. Now, I'm not saying that you need to learn how to do these equations from your head and memorize all the equations and formulas. What I'm saying is focus on understanding the principles and how they work. And these skills often translate well into practice. I actually use FBDs, free body diagrams, almost every day. It's an essential skill that you need to know, and how to solve for them is very vital. Actually, most interviews you're going to have are most likely going to have an FBD equation in there, and if they don't, then I'm not sure they're looking for a mechanical engineer. All right, skill number 2, CAD, computer-aided design. What's a mechanical engineer that doesn't know how to do CAD? In fact, it's probably one of the most fun things we do. We get to design things on the computer and then create them in real life. And I do recommend that you start early getting really good at creating designs in CAD. Now, when I started, I learned SolidWorks. That doesn't mean that you need to learn SolidWorks. In fact, in university, I learned SolidWorks. But in Apple, we used NX. Actually, in Google and Facebook and several other places, they use NX as well. But that doesn't mean that you need to know NX. I'm just saying that those are common software. And what I use today is actually an online tool called Onshape, which is free to use. It's on the browser, and it's really awesome. It has most of the things you need, and as a student, you'll get it for free. Come in, you check it out, and there's actually a video, I'll link it somewhere here, about a tutorial that I show how to use it. All right, next is a solid understanding of manufacturing principles and materials. Now, one thing that I used to do when I was younger is I would tinker a lot in the machine shop. I'd actually bother the machinists a lot, asking them a whole bunch of questions, asking them to, can I try and, machine something with you, or can I, you touch some of these samples and see how they feel. And what I mean by that is, I think one of the best things that I did was I went to the machine shop, I took materials, say aluminum sheet metal, steel sheet metal, maybe plastic parts, and I would bend them and twist them and feel how they felt in my hands to give me a really good idea of, hey, this material feels like this is how it behaves. If I was ever going to design with this material, these are the sort of properties or physical attributes I could expect from them. And if you get familiar with materials, using them and like actually feeling them, I think you'll become a much better engineer. You'll have a much better intuition. Now, in terms of manufacturing processes, there are so many. And I don't think anyone expects you to know all of them or even most of them. In fact, there's new ones being developed every day. What's important though is to understand some of them at a fundamental level. Some of the main ones that are used every day, for example, CNC, stamping, even additive manufacturing now, injection molding. Have a solid understanding of how they work. Watch videos online, and if you want to learn more about any of them in particular, please leave a comment below, and I'm happy to share more. All right, the next skill we're going to talk about is a strong analytical and problem-solving mind. Now, unlike before where we talk about a mathematical proficiency, this time we're going to talk about more of how to take problems and boil them down into smaller and smaller solutions. When you start to solve for these big problems, for example, when you're building a car, if you look at the car as a whole body and a system, that's very good, but you'll need to understand the underlying structure beneath it and the systems that are beneath it that you need to design for. For example, in an electric car, you'll have an electric motor, you'll have the wheels, you'll have the chassis, you'll have the outer frame, you'll have internal circuitry, the compute. So understanding the problem-solving aspect of this entire system and boiling it down to the smaller chunks will help you become a much better engineer. And I use this type of thinking all the way till today. Solving problems, learning how to solve problems well, and mastering that is fundamental. And next we're going to talk about learning how to communicate very well and learning how to present yourself very well. Most of the time, you're not going to be talking to another mechanical engineer. Sometimes you're not going to be talking to someone who knows mechanical engineering very well. For instance, you might be talking to your peers in software or electrical engineering, maybe design, and even sometimes in the business world. When you talk to them, they're most likely not going to understand the fundamental technical challenges that you're facing. So being able to communicate it very clearly and helping them understand is extremely vital. And I do recommend you think a lot about how to present yourself well, practice speaking, practice presenting, learn how to do good presentations, learn from peers, get feedback on how to do better presentations. And if you want to learn more about presenting, please let me know or leave a comment below. I can share my tips and tricks that I've learned through the years of presenting many times, pitching to companies, and I do recommend learning more about how to present better and how to communicate better. Creativity and innovation is a very important skill that we often lose throughout our careers. And that's usually because as we practice our engineering, we often get sucked into doing things the same way. And I do recommend really being mindful of that, really questioning why you're doing something. Sometimes, to be honest, to be really, really honest, you may not have that flexibility. You might be forced to go down a route that you don't really agree with, or that's just done and you just have to do it. But I do recommend is keeping your mind open. If you are forced to do things the old-fashioned way, and just because it's the old-fashioned way, I do recommend working on your own projects and keeping a clear, open mind and a creative mind, because without the creative mind, why are you an engineer anyway? You're meant to design and build things and innovate in this world. And so I do recommend really being as creative as possible. Next thing we're going to talk about is adaptability and forever learning. And that's something that I pride myself a lot in. In fact, get a lot of feedback and be open to that feedback and keep learning from those mistakes you continually make. And don't be afraid of it. I know that it's very hard to get feedback sometimes. I actually felt like that a lot. I would feel very overwhelmed or very anxious to receive feedback. If my manager would pull me aside and say, hey, can I give you some feedback? I would be pretty scared at the start. And I realized that the more feedback I got, the better I became. And that's a given, right? The more you learn, the more feedback you get, the better you can become. But what I recommend is not to be too afraid about getting that feedback. And sometimes that feedback can feel harsh at the moment. But what's really nice is when you get feedback, you're going to become better at that specific part. And you might start to become better than your peers. You might become better than the person that's giving you feedback. But in those instances, what I recommend is take that feedback, try and distill what is actually useful to you to become better, and then use that and implement that, because what's the worst that can happen? You're just going to be a better person, right? So keep working at that and keep being better and get that feedback, keep learning and keep discovering things. And on the same topic, look out for new emerging technologies all around you. Work with your suppliers, work with your mentors to understand what are the manufacturing processes, for instance, what are the technologies that are new and innovative that you can use and implement in your life. Teamwork and project management. Now, teamwork is a given, right? You need to work in a team. It's not you. You're generally not the only person in this company. Even in a startup, it's generally not you alone. So you need to work very well as a team. So learn to cooperate, learn to coordinate, learn to delegate and trust each other and be someone that can be trustworthy as well. But in terms of project management, that's something that's overlooked oftentimes. And I did this very poorly when I started. Managing my time, managing expectations, working with a manager to understand what are the key deliverables that need to be done and working at them one by one and really focusing on what's most important, what's most valuable to the company, to the project, and then working towards that. And what's awesome is this skill transfers into the bigger picture over time, especially if you want to go into a management track and you want to look after a bigger company and a bigger organization. Knowing how to manage your time and a project and a team is extremely vital. This kind of project management skill will never go away. And so I do recommend really focusing and honing the skill as much as possible. And I do intend to make videos about management and team structures in the future. So subscribe if you want to learn more about that in the future. All right, let's talk about 2 bonus skills that I really wish I had learned earlier and that would have helped me in my career. Number 8 is thermodynamics and fluid mechanics. When I was in robotics, I had a very basic course in fluid dynamics and thermodynamics, and I actually didn't like it too much. I was quite bad at it. In fact, I barely passed the exam. But I wish I put my head down a bit more and would focus a bit more in those courses because I use it almost every day. In fact, around us, everything is reliant on thermodynamics or fluid mechanics to an extent. For example, the phone or the laptop you're watching this video on, it's drawing power from a battery. That battery has thermal capacity. It's either heating up or cooling down depending on, how it's being used, right? And so that heat has to be transferred somewhere. The processor, it is transmitting heat because it's processing the information. So it's super critical to know thermodynamics and then fluid mechanics as well, understanding how fluids flow in different bodies, how viscosity, and these kind of fundamental ideas of how fluid works, because it'll be coming back at you in many different forms, whether you work in automotive or rocketry, whatever kind of job you have in the future. It's going to be super critical to know these fundamental skills in thermodynamics and fluid mechanics. All right, and number 10 is programming. And this is an interesting one, right? I don't know if you're a mechanical engineer, if you actually thought much about learning how to program, but because I studied robotics, I was privileged enough to learn programming in every single one of my semesters. I learned C++, I learned C#, I learned JavaScript, and it was really important for me to learn these things because later on I learned that because I know this, I'm better able to communicate my needs to my software engineering peers and I'm able to do things that other mechanical engineers just can't. I can think of solutions in ways that they can't. For example, I know how FEA code is made, and so I understand at a base structural level when I'm setting up my FEA simulation, what is actually happening in it. And so I'm able to create much more accurate FEA simulations because I'm able to apply the learnings of software into my application of FEA. So I do recommend learn software, become a better engineer through it. And even if you don't use it in mechanical engineering in particular, in the future, if you ever make a startup, if you ever make your own company, if you ever make your own YouTube channel, you'll be able to create websites, software, tools, whatever you may need in any domain. So there you have it. 8 tips plus 2 bonus tips to help you become a better engineer that I wish I knew when I was younger. Now, if you found this video useful, I do recommend you check out this one here, which teaches you more about product design engineering from a base level. And this video here can teach you more about material science. And if you want to learn more about business, engineering, entrepreneurship, subscribe to my channel. You'll learn more there. Thanks a lot. I'll see you.